In this video, I'll go through and demonstrate another example of balancing chemical equations. However, I'm going to use an example that involves an atom that exists in multiple either reactants or products. So for this example, I'm going to choose problem number 9, which represents the combustion of octane. So I've already written the example on a fresh sheet of paper so that you don't have to worry about looking through all those other reactions, so that we can focus on this one chemical equation. So I already have my skeletal formula, which just represents the correct chemical formulas of my reactants and my products. However, I haven't balanced it yet. So again, I like to write my atoms under the reaction arrow. And remember, the reaction arrow is what separates your reactants from your products. So I write the types of atoms that are involved there, and I simply indicate what's located on my reactant side as well as my product side. But keep in mind, the law of conservation of mass tells us we need the same type and number of atoms on both sides of the chemical equation. So we have to look at the entire reactant side, the entire product side. So my entire reactant side, each atom exists only or appears only one place. So I have 8 carbon, 18 hydrogen, 2 oxygen. Product side, that's not the case. My carbon and my hydrogen each appear only one place, but my oxygen appears in both compounds. So you have to make sure that you account for all of those oxygen atoms. So I have 1 carbon, I have 2 hydrogen, but I have a total of 3 oxygen. 2 from the carbon dioxide, 1 from the water. So right now, nothing is balanced. So again, you can add coefficients. I have more carbon on my reactant side, more hydrogen on my reactant side, but I have more oxygen on my product side. However, if you look at this reaction, oxygen appears in 3 out of the 4 compounds. One little trick when you're balancing chemical equations, if you have atoms that appear in multiple either reactants or products, save those for later. So don't start by balancing those, because what's going to happen is as we balance the carbon and the hydrogen, it's going to change the number of oxygen as well. So if we start with the oxygen, you can still get the right answer, but it'll just take you longer to get your balanced chemical equation. So if you do manage to start with oxygen, don't give up. You'll just have a few extra steps. So in this case, we can choose to start with either the carbon or the hydrogen. So let's just say I started with the carbon, since it's written first. I have 8 on my reactant side, 1 on my product side. On my product side, my coefficient is 1. So whatever my coefficient is being multiplied by 1. I need 8 carbon, so I can just add a coefficient of 8. When I add that coefficient of 8, it's going to change the number of carbon and oxygen atoms. So now I'll have 8 carbon. I'll have 16 oxygen from carbon dioxide, but you can't forget about that 1 from water. So you have a total of 17 oxygen on your product side. Right now the carbon atoms are balanced, but nothing else. So let's say we want to now go and balance the hydrogen. I have more on my reactant side, so I need to add a coefficient to my product side. My formula H2O, so I have that subscript of 2, so whatever I add as a coefficient is being multiplied by 2. I need a total of 18. So 2 times 9 would give me 18. But again, when I add that, it's going to change the number of hydrogen and it's going to change the number of oxygen. So although I have 18 hydrogen, now I have 16 oxygen from carbon dioxide plus 9 oxygen from water for a total of 25 oxygen. So you see, as we change the coefficients on the product side, because oxygen was present in both compounds, it changed the oxygen each time. So if we had started with that, we would have still had the same problem. We would have balanced our oxygen, but then as we went and balanced the carbon and hydrogen, it would have changed the oxygen, and we would have had to go back and balance it again. So again, you can still get the right answer, but you'll just have extra steps. So now we need to go and balance our oxygen. We only have oxygen one place on the reactant side, and so it has a coefficient of 2, so we need a number that we can multiply by 2 to equal 25. There's no whole number that we can multiply by 2 to equal 25. So please keep that in mind, that when you're balancing chemical equations, you need whole numbers, no fractions. So if you encounter a problem like this and you need a whole number, what you want to do from there is go back and double the reactant component. Or you can even go through and finish balancing this here. Because I know if I multiply 12.5 by that 2, so if I put 12.5 times 2, that's going to equal 25. But that's not a whole number. So if you ever encounter something like that, you can go ahead and balance it this way. But then, now that my carbon, hydrogen, and oxygen appear to be balanced, I need to go by and multiply everything by 2. Because you must have a whole number as your coefficient. So what this means is that now in front of my octane formula, instead of that invisible 1 that we had, now I'll have 2. In front of my oxygen, that O2 molecule, instead of that 12.5, now I have 25. In front of carbon dioxide, instead of 8, now I have 16. In front of my water, instead of 9, now I have 18. You can go back and double check to make sure that everything is balanced. So if I look at the number of carbon, hydrogen, and oxygen on each side, again, they only appeared on one place on my reactant side. So I had 8 in this molecule times 2 for a total of 16. 18 hydrogen in this molecule times 2 for a total of 36. 2 oxygen in this molecule times 25 for a total of 50. Product side, 16 CO2, so 16 times 1 for a total of 16 carbon. I only had hydrogen in one place. It had a subscript of 2. Multiply that by my coefficient for a total of 36. But then you have to make sure you account for all of your oxygen. 2 times your coefficient of 16, so I have 32 oxygen here. But I have this subscript invisible 1 times 18. I have 18 here. So my 32 oxygen that are present in CO2 plus my 18 oxygen present in H2O for a total of 50 oxygen. So this would represent your balanced chemical equation. You want to make sure that you do not use fractions as your final answer. They can help you reach your final answer, but your final balanced equation must use the lowest ratio of whole number integers.